So you saw a simple problem which involves two cars, right? And you calculated relative velocity of one car with respect to other. So both were moving in the same on the same line, right? So that's linear motion, one-dimensional linear motion. So in that case, you can merely add the two numbers or subtract, and you can get the answer, right? But what happens is that when it comes to two-dimensional scenarios, then you're gonna have to use vectors, right? Or you can use algebraic method. So I'm gonna discuss a problem which can be done using algebraic method and also using vectors, right? So if you can remember addition of vectors, like the triangle, then this will be easy for you. So I will discuss this problem in two different methods, right? So first, so the problem will appear here now, and go through that and try to write down the data first, right? So usually we take this direction to be north, so mark it somewhere, represent what north is, and I mentioned what these letters represent. So C represents the cyclist, so this problem is about a cyclist. W represents wind, and E represents earth. So it's easier for us to do these calculations when we represent these letters. To a cyclist riding due north at 8 meters per second. Due north, you can say that due north. This part represents in the direction of the north, right? Due north. Utturata, due north, right? So north is in this direction, so we have to get the direction. Due north. The cyclist is riding due north. Direction එක විතරයි කියලා තියෙන්නේ. ඊට පස්සේ කියනවා මොකද? At 88 meters per second. At 8 meters per second. So 8 meters per second. Due north. So due north කියලා ගත්තාම එතකොට cyclist riding due north relative to earth තමයි මේ කතාව කියන්නේ. Right? This is about relative to earth. So we can write it like this, right? Velocity of cyclist with respect to earth, or velocity of cyclist relative to earth, is 8 meters per second due north, right? Represent මේ data එක පෙන්න. Then the wind appears to blow from a direction. Wind appears to whom? අන්න ඒක ඊළඟ එක. appears කිව්වහම you should know that this implies relativity. So to whom? To a cyclist, right? To a cyclist riding due north, the wind appears to blow from, right? Not due, from, right? Wind appears. එතකොට cyclist තමයි මේක තේරෙන්නේ. So velocity of wind relative to cyclist මොකක්ද කියලා කියනවා දැන් නේද? Blow from direction 60 degrees east of north, right? First, what is east of north? East of north. මෙහෙම ලිව්වහම කොතනින්ද rotate වෙන්නේ? කොතනින්ද ඒ කියන්නේ angle එක measure කරන්නේ කොතනින්ද කියන්නේ මේ මෙතනින් ඉඳන් බලන්න, right? East of north. Of is related to this. East of north. So north එකෙන් පටන් ගන්න. north වලින් ඉඳන් east වලට කියලා කියන්නේ. north වලින් ඉඳන් east එකට 60 degrees east of north. So මෙතනින් ඉඳන් east පැත්තට, right? If this is north, this is east, west and south. And මෙතෙන්ට ඔන්න direction එක, right? මේක මුලින් mark කරගන්න. This is 60, right? They say due කියලා කියන්නේ නැහැ. It says from a direction. From කියලා කිව්වහම due කිව්වොත් මෙහෙ පැත්තට. Due කිව්වොත් මෙහෙම. From a direction means in this direction, right? In this direction, right? From. तर ඔයා මෙතන ඔයා cyclist කියලා හිතන්න. ඔයාට තේරෙනවා අරින් ඉඳන් එනවා. Right? So we have to represent that as well. Appears means velocity of wind relative to cyclist. It appears to come from 60 degrees east of north, right? ඔන්න මෙතන north එක 60 degrees මේ බලන්න arrow එක තියෙන විදිහට. Now here's the arrow in this direction, arrow, right? Okay, and they're asking us to find what is the true velocity of the wind. True velocity of the wind means what is the velocity of the wind relative to earth. මෙන්න මේක තමයි ගන්න. Right, now we can use the equation for the relativity. So we need to find this, so let's make this subject. So when you do this, velocity of WE must be equal to velocity of W relative to cyclist plus velocity of cyclist relative to earth. Right. So velocity of cyclist relative to earth, velocity of wind relative to cyclist is this, 60 degrees, මේ පැත්තට 460. Then cyclist 8 meters per second, upward 8. Right. Now we need to find this one. So දැන් අපිට මේක ක්‍රම දෙක තුනකට කරන්න පුළුවන්. Right, so there you can use algebra to find this. Now you can see that when you add these two, 4 cos 60 is in this direction, downward 4 cos 60, and upward you have 8. Right? 4 cos 60 means 2, upward you have 8. That means you have a resultant due node, right? Resultant due node. මෙහෙම එකක් තියෙන්න පුළුවන්. මේ දෙන්නක add කරා. Then 4 sin theta in this direction. 4 sin theta in this direction මෙහෙම එකක් තියෙනවා, which means the resultant of these two must be in this direction, right? So let's represent it. Let's say the velocity is v and theta. මෙහෙම ගන්න. Right. This is method 1. Method 1. So we can use algebra. Once we have represent this, I can get two equations because I need to find velocity and I need to find angle, which means I need two equations. So first equation, v cos theta, if you resolve all components in this direction, v cos theta must be equal to the resultant velocity in this direction on the right hand side. So we have 8 upward and minus downward we have 4 cos 60. 4 cos 60. Right? So 4 v cos theta 8. This is minus 2 equal to 6. This is equation 1. Then in this direction, if we resolve in this direction, we have v sin theta. V sin theta equal, we don't have any components from 8, only 4 sin 60. 4 sin 60 is 2 root 3. This is the second equation. Right. Now what you can do is, if you want to find this angle, you can divide 2 by 1. If you divide this, you get tan theta 2 by 1. 2 root 3 divided by 6. So we get root 3 divided by 3, which is 1 over root 3. So this implies theta is equal to pi over 6. Theta is equal to pi over 6. Right. Now if you want to find velocity, I can substitute this in any of these equations. So let me use this one instead. From 1, v cos pi by 6 is equal to 6, which implies v is equal to root 3 by 2, so 12 divided by root 3. V is equal to 12 divided by, right. So 12 divided by root 3, if you rationalize the denominator, then you get 4 root 3 meters per second. Right. So this is method 1. Now, when you get questions in the exam, you can't always resort to this method because, in this method you have to know in which direction the velocity is. You have to guess it. but there's an easy way to deal with this stuff, because this is algebra, and this is algebra, and in applied mathematics we tend to use graphical methods, right? Graphical methods, so that we can get to an answer very easy, right? So let's use theorems of velocities to get this answer. Let's look at method 2, right? So notice here I don't have to find what it is, right? So let me replace it with v or something, whatever it is. Now let's use law of addition of vectors, right? Always make sure if you have any vector in a vertical direction or horizontal direction, you always start with this one, right? You always start with that vector. If you have an inclined vector, then you move on to that the next time. It's always easier to start with a vector that is either vertical or horizontal. So 8. First, මේ vector එක ගන්නවා. මේ vector එක අපි තනකින් පටන් ගන්න. This is the initial point. So it has to go upward by 8. So make sure this length is 8. So you don't have to use any scales. But when you represent two vectors, you have to make sure that their magnitudes make sense, right? Then 4 meters. From this you add this, right? එතකොට ඕලන්ට එනවා මෙන්න මෙහෙම එකක් 4 meters. 4 meters means half of this length. ඒක නිකන් බලලා පොඩ්ඩක් කරන්න. Half of this length. එතකොට 4 meters. This is 60, that means this is 60. For 60. Right. Okay. Next, may starting point. This is the terminal point. So our velocity, the resultant must go from starting point to end point. This is our resultant. ඔන්නෝම ගන්න. right. ඒතර මේ වගේ තනක් ආවහම මෙන්න මේ ක්‍රමේ පොඩ්ඩක් උරු වෙන්න ඕනට හොයන්න ඕන velocity තියෙනවනේ. Make this hypotenuse. Try to construct a right angle such that this side is the hypotenuse. මේ side එක hypotenuse එක එන විදිහට right angle triangle එකක් හදන්න. මේක පොඩ්ඩක් ළඟට ගන්න. බලන්න. Now here, let's make this hypotenuse. What I do, I'm gonna draw a dash line like this. So now it became a right angle triangle. So let's name these points. So let's call it P, Q, and R. Right. So now we can see that here we have an angle theta. We need to find this angle theta. Okay. දැන් පේනවනේ කලින් අපි මෙහෙම ගත්තේයි කියලා. දැන් මේක ගත්තට පස්සේ අපිට බලන්න පුළුවන් මෙන්න මේ වගේ. We can use cos theorem. Cos theorem එක පාවිච්චි කරන්නත් පුළුවන්. සමහර ගණන් වලදී 90 degrees වගේ එනවා. right angle triangle එකක් වගේ ආවම ඒතර කෙලින්ම අපිට ඒක පාවිච්චි කරන්න පුළුවන්. We can use Pythagoras theorem. But this is a general case. මේක general case එකක් හින්දා අය බලමු මොකද වෙන්නේ කියලා. දැන් මේක 90 degrees වෙලා තියෙන්න පුළුවන්. හරිද? right. අපි බලමු. ඒතර in generally this is what you do. You find this 8 RS, let's call this T, right? So what is RT? RT is, this direction is 4 sine 60. RT is 4 sine 60. Okay, 4 sine 60 means root 3 by 2, so 2 root 3. What about PT? PT is 8 minus this 4 cos theta, 4 cos 60. 8 ගෙන් මෙන්න මේ කැලල ඩිඩක්ට් කරාට පස්සේ මෙන්න මෙයා තමයි PT. So 8 minus 4 cos 60. So this is the answer is 6. දැන් අපිට V ගන්න පුළුවන්. What is V? So V is, now we can use Pythagoras theorem, square root of RT squared, that means 2 root 3 whole thing squared plus 6 squared. So answer ගත්තාම we get 4 into 3 means 12. This is 36. Then root 48 වෙනවා. Root 48. Root 48 means 16 into 3, 16 into 3, so therefore the answer is 4 root 3 meters per second. V, right? So if we want to find the angle like ganna pulan kelimma tan theta RT divided by PT. So RT is 2 root 3, PT is 6. So theta is in this case tan inverse 1 over root 3 pi by 6. Right? මම මේ කලින් ගත්ත හින්දා මම කෙලින්ම දෙන්න. ඒතර මේ අනිත් ක්‍රම most of the time we are going to use this method. Right? We draw a triangle and use properties of vectors to find the answer. හරිද? ඒතර මේ method දෙකෙන්ම කරන්න පුළුවන්. ඒතර තව ක්‍රමයක් තමයි මේ triangle එක ඇඳලා පස්සේ we can use cos theorem, right? Cos theorem to get the answers. Let me show you how to do that one as well. Right, so cos theorem, so we know these two sides and we know the angle, so we can do the apply the cos theorem for this triangle. So cos 60 may angle cos 60 must be equal to 4 squared plus 8 squared minus v squared divided by 2 into 4 into 8. Right. So cos 60 is half. When you cross multiply, you get 32. Then 16 plus 64 minus v squared. So v squared is 48. Therefore, v is 4 root 3. Right. It's another method. ඊට පස්සේ theta හොයන්න ඕන. Again, you can use cos theorem. Cos theta equal v squared plus 8 squared minus 4 squared divided by 2 times v into 8. එතකොට cos theta හොයන්නත් එනවා. මම ඒකත් කරලා පෙන්නනවා for the sake of completion. So if you want to find theta, first you find cos theta, that is equal to v squared. V squared means 48 plus 64. 8 squared means 64 minus 16 divided by 2 into v was 4 root 3 into 8. Right? So මෙතනදී මොකක්ද දෙන්නේ බලන්න. Right here, so this becomes 96 divided by 16 into 4 root 3. This is 6 divided by 4 root 3. Right? So here 3 divided by 3 divided by 2, which means root 3 by 2. So this implies theta is equal pi over 6. Pi over 6 means 30 degrees. බලන්න මේ ගාන මෙයා 30 degrees වෙනවා. 30 degrees means this would be a right angle triangle where this is the right angle. So right angle triangle එකක් આવොත් ගාන ලේසි. එහෙම ආවේ නැත්නම් මෙන්න මේ විදිහට කරන්න. Right? මේ විදිහට කරන්න. Right. So let's move on to another example.